Hi everyone, welcome to my channel again. So in this video I will talk about Udacity's self-driving car Nanodegree. So this is a program that I took sometimes last year. It took about 9 months or so to complete while also having a full-time job. So this is only maybe 1 to 2 hours a day dedication to the course. The version that I will be talking about is the 3-semester curriculum, which from my understanding has been changed right now, and it's only 2 semesters, but from just skimming through their syllabus it seems like it's the same it's pretty much the same course, the same assignments. Maybe they took out some projects and so on. So first I will talk about this Nanodegree, what it is, and more importantly what it isn't. Then I will talk about projects that you will end up doing in the course, and finally I will answer the question, can you actually program a self-driving car at the end of this course? Okay, so here we go. So what is a Nanodegree? So a Nanodegree is just a fancy name for a collection of tutorials that is put forward by Udacity. Don't let the name fool you. You do not get an actual degree, like a college degree or university degree. However, from all these online learning resources like Udemy, edX, TED, and so on, I think the Udacity one is the most complete one. Also, in terms of the self-driving car curriculum, it's the most complete course that encompasses all areas of self-driving cars that they have ever found online. So in the best case, it's a very, very well explained curriculum and a very well curated list of tutorials and so on. Another thing that I wanted to mention, that this is not an accredited university course and it's not a university degree like I mentioned before. However, it is taught primarily by Sebastian Thurn, which was a university professor and who also worked at the Google self-driving car. And the way he explains some of the concepts in the videos are absolutely phenomenal and fantastic. I don't think you can find a better tutorial online on some really hard questions like localization for cars or computer vision or anything that has to do with robotics and the way robots perceive the world. So I highly recommend this course only if it's for this. So just to make it clear, I really enjoyed this course a lot, and although it's not a university course, it's a really good resource to learn a lot of things. So the self-driving car Nanodegree, it's set up in 3 different sections, as you see here. First section is computer vision and deep learning. The second one is sensor fusion, localization and control, and the third one is path planning, concentrations and systems. So as you see here, it's quite a lot of material that you go through. This is only for, actually this is only term 1 that I'm scrolling through here. Not term 1, actually yes, term 1, but only the computer vision and deep learning part. So let's go through each of the 13 or 14 assignments one by one and explain a little bit and show you kind of what you get to do in it and how interesting it really is. Let's go. In the first project of the Nanodegree, we get to do this really interesting project, which is to find, to detect the lane markings on a video provided to us. And this is just like a little snippet from one of the courses that you go through. Basically, one of the main concepts here, you use hook transformation on an edge detection image. So basically, you start with the image on the left and you end up transforming in different spaces, in different color spaces, and you end up detecting lines like that. It's really interesting how that works. And then by eliminating some lines in a certain direction, you end up marking the ones that belong to the lane. So at the end of it, you end up with something like this. So this is my particular my result for this project, as you can see, is not perfect, but that's part of the fun. So it's really interesting to create, just take a video and then be able to detect the lanes on it just using some computer vision. This doesn't use any deep network, any neural networks or deep learning or anything like that. It's just some fundamental stuff, and it's really fun. Project number 2. So here we start with neural networks. You end up in one section writing like your own TensorFlow library. It's called MiniFlow, which is really fun to write. Then you actually get an introduction to the real TensorFlow library that is used by Google and developed by Google, but used by many professionals around the world. Then you get some really in-depth lessons with deep neural networks, and then convolutional neural networks, and then you get to the net for traffic signs, which is it's a particular convolutional neural network architecture specifically made to detect traffic lines. And in the project that you have here, it's basically a traffic sign classifier. You get this data freely available online of many different labeled traffic signs, and basically implementing Ian LeCun's traffic sign recognition research paper using this particular architecture, you will end up classifying correctly a bunch of traffic signs. And then as a challenge, you get to pick some random signs from the internet. So I chose these ones and tried to detect them with your own classifier, and mine had an accuracy of about 60%, which is good enough for the first time writing a classifier from scratch. So I'm not going into too many details about this project. I will have the links for the GitHub project for my solutions on the YouTube description page. I am just doing an overview right now of the entire course, so that you get a really good idea of the project. Okay, so that's project 2. So project number 4, this is probably the funnest of all. So in here you get to learn something called behavior cloning, and it's a really fun project. You get the simulator written in Unity, where you go initially in this training mode, and you drive the car around the track like this. You try to keep it in the middle of the road, so make sure you don't go on the sides. And as you're doing this, there's a special mode to start recording. It basically records each frame and the steering angle. So as you see in the upper left corner, there's an angle there. The steering angle, it goes between minus 25 and plus 25. So anyway, you're recording thousands of pictures, and each picture has a steering associated to it. And at the end, when you're done with this, you're running through your own model of convolutional neural network, which is used for behavior cloning. And in the end, you get the car to drive again, and it should drive by itself on the road. This is on the same track. This is the result I submitted. As you can see, it drives pretty nicely, and it will go around the track nicely. This was by far my favorite project, and I'm going to do a separate video only about this project, how to actually get it to work, and explain how everything works and how to actually make this work. So this is project 4. So for project 4, we have, it's called Advanced Techniques for Lane Finding. So you basically just improve on computer vision techniques to do more advanced lane finding techniques, this time with curvature and area of the actual lane. So here's the result of that. This one was really interesting. This is just computer vision stuff. You learn a lot of interesting stuff. So as you can see now, you can predict where the lane is actually going there. So there's a little bit of a curvature to it. You can even calculate the curvature based on the US standards. Also, the center offset is basically how much the car is offset from the middle of the lane. So that's also an interesting thing you can calculate. Now, as you can see now, when the road is a little bit with shadows in it and stuff, it doesn't behave quite as correctly. You can make it as correct as you want, but what I had here was basically good enough, and it was super fun to work on this project. So this is project for advanced techniques for lane finding. Project 5, it's called vehicle detection and tracking. This one is really cool, basically given a very similar video of what we had so far, using some more advanced machine learning techniques such as support vector machines and just object detection techniques. You get to detect cars in a given video. So the result that I have looks something like this. It is not perfect by any means. It will give some false positives. I wouldn't want this necessarily to go in a real car, but it's pretty good if you check it out. So the important thing is for it to pick up this car here on the right side. Also, I think there's another car coming through. Also, it's nice that it's picking up cars on the left side also. So there's another car coming in, it's picking up, it's understanding that there's two cars right there. So this is pretty much the object detection project that you get to do, which is pretty nice. So project number 6, this one is called Unscented Kalman filters. So this is the second part of the Nanodegree, where you start doing basically sensor fusion, and you understand how cars use data from different sensors like radar and lidar, and maybe localization sensors and GPS and so on, fuse it all together and then make decisions on that. So the first example, the first project rather, it's a project where you basically write your own Kalman filter, which will fuse I think radar data and lidar data. So you get this kind of simulation here where you have a car and that is tracking a virtual bicycle, and you're basically just given the data as a data file. You start it up like this, and basically the program is feeding in the data as if it's a radar and a lidar installed on your thing. And basically this program, when you start, it's basically plotting where the bicycle would be, like where the green thing is. It's not very intuitive unless you actually do it. I will make another video explaining how this one actually works. But this project and the next one, which is number 7, is very similar. So let's go to number 7 in 1 second. Okay, this is project 7. So in project 7, it's called Unscented Kalman filters, and it's pretty much the similar type of project as the extended Kalman filter, but it's just a different filter that you have to implement, and all the details and so on are in the curriculum. And when you start this one, it's basically providing the same type of data, and it has the same functionality. It has to work in the same way, but you're just using a different type of filter. In project number 8, this one is a kidnap vehicle project, which is similar to the previous 2 projects. It's using particle filters to fuse multiple sensory data and combine it with a real-world map to locate a runaway vehicle. So we can start it from here. We can start the particle filter. Right. And then, okay, so basically these are waypoints given from this map data, and you can see that the vehicle is being tracked based on those waypoints. More explanation than this, I will create a separate video. Actually, I will create a separate video for every single project to see how I actually came up with a solution, but that's to come later on. So in the meantime, here's the kidnap vehicle project that you'll be doing during the Nanodegree. Okay, in project number 9, you basically implement PID control, which is like one of the first things you learn when you do robotics, and this is to basically control the steering of the car. So again, you get a nice little simulator, which you can start. Okay, and then we basically start the PID controller, and as soon as I started, like the car is basically using my implementation of the control for throttle and steering input. So that's all for this project. It's also pretty fun, but this is probably one of the shortest projects, and I don't think they do it again in the new curriculum, but I might be mistaken. Okay, so project 10, it's called MPC Model Predictive Controller. So this is a more advanced way to get your car around the track. So similar to the PID controller, you basically implement a different type of controller, which, as you see, the yellow line is where it's trying to go, and the green line is where it's currently heading. Now this is running poorly on my Mac computer. Actually, it's not too bad, but this should run better if you run it on a desktop computer or on a Windows PC with a proper video card. Whoa, that was close. It's pretty nice. You get to learn about splines and so on, how they work. Wow, it's can't believe it's doing so well, considering I'm also recording the screen at the same time, so the frame rate is really crappy. Cool. Okay, so that's the MPC controller. Okay, so this is project 11, path planning. This is the first project of the part 3 of the Nanodegree. So in this project, you basically make a car drive on the highway, and it will know when to change lanes. When there's other cars around it, it would plan, like it would know if there's space to change lanes. It would slow down, it would accelerate a little bit. Pretty much a lot of the stuff you've already learned before goes into this project. This is a really fun project, and it's the first time when you actually see some real stuff going on in here. So the green dots are basically how far the car can see right now based on waypoints, and let's just let it run for a little bit. So once it hits a little bit of traffic, it would basically slow down, or it would change lanes or so. Okay, there's no traffic right now. It's programmed to keep the lane if it doesn't have any obstacle. Let's see, usually somebody changes lanes in front of you. Maybe this guy. Nope. This is a pretty boring demonstration. Let's do it again. Let's start again. Usually. Okay, here we go. So we will hit some traffic right now. Oh, nobody's changing lanes in front of me. Okay, I will put this in manual mode. Oh. Worst example. I hit manual mode exactly when the guy changed into me. So I will put it in manual mode so that I can go. Okay, now it's on autonomous mode, so let's see how it can handle this traffic. So this is an empty spot, it will pass. Changes lanes again. So that's pretty much the essence of the project. You're supposed to implement this kind of behavior, and there's a lot of math involved, mostly with splines, but it's not really all that bad. Okay, so this is project 11, pathfinding. Project 12. Okay, and I didn't set this up, so we can delete some of the stuff, or I can just talk idly for about 2 minutes while I set up the screen recording. Okay, I will just talk here. So setting this up, start recording. Okay, so for this project, this is called Semantic Segmentation, and it's a more advanced deep learning project. What you end up doing is you're using a fully convoluted network, and you're using this thing called the KID dataset for training a model that will detect the road pixels images or videos or a sequence of images. So this is the end result at the end, where you basically have an image and you're supposed to paint each pixel that belongs to the road. Now, semantic segmentation is a really nice area of computer vision, and what it does is basically you take each pixel from an image and you color it based on what it actually means in the image. So in this case, it's a simple case where we only paint the road with the green pixel, but in other projects you might paint the road with a certain color, another car or cars with a different colors, maybe cars that are moving will be yet another color, and then an algorithm can pick up this image and make a decision right away based on the color of the pixel. So this is project 12, semantic segmentation. So project 13, this is the capstone project, is the biggest project of the entire course, and in this one you will actually program using ROS, or Robot Operating System, which is industry standard for robotics, and it made its way into self-driving car technologies. And the purpose of this project is mostly to collaborate with a few other people. You can do it yourself, but it's recommended you do it in a group of people. You can be self-organized, usually on Slack or something, when to meet and when to actually work on it. There's a few different parts of the project. You're supposed to implement a traffic light classifier that detects traffic lights in a simulation, and then also a different model for real world. And you're supposed to set up this entire ROS system that I'm showing here. And then at the end, to pass the project, you only need to get your car to go around the track, similar to what you've seen in project 11, I guess, for path planning. But the really fun part is that the way you deliver this project, it's just like in the real world, using a bunch of ROS files, and the guys from Udacity will take your code and run it on Carla, which is the self-driving car that they have in San Francisco at the Udacity headquarters. They will actually run the code in a parking lot. It will just go around the track once or something, and it will record the performance of your car. So and then you'll get a video with that, and that is really awesome. So you can create a nice portfolio project where you say that the code that you wrote actually went on a real self-driving car project. What I have here is just a GIF from the actual project website. It's impossible to set up everything right now to show you the ROS in a short video, but maybe I'll create another one, that another video that will cover just how ROS works and how this entire project works. Okay, so in the end, as a conclusion, after seeing all these projects, can you program a self-driving car by yourself after taking this course? And the answer is maybe. So you definitely get enough skills that you can take a small toy car and program it to drive around your room or your house on its own. You could technically, at least I feel that I have the skills, that if I could get a real car and hack the steering and the throttle system, I could probably get it to work autonomously under ideal conditions. So that means in North American highways or in a suburban street where everything is clear and everything is marked well. But of course, I would not be able to cover edge cases or even normal cases, like if it's raining or snowing or more real life scenarios. So I felt that this course gave me a lot of depth. I think it pretty much covers every area of computer vision and deep learning and everything that and robotics, basically everything that you would use in self-driving cars. But in order to really learn how these things work, you have to build your own, or you have to work for a company that are currently commercially working on these project. There's no other way to fully understand how everything works. But having said that, this project, this Nanodegree, is a really good starter, and it's by far the best collection, a curated collection on all the concepts on self-driving car notions and concepts and so on. So I highly recommend it. So that's it for now, and I'll see you next time with a more interesting video. Bye bye.